law. In this lecture we find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of this triangle equals to 13 units in its length, side BC equals to 14 units in its length, and side AC equals to 15 units in its length. Our mission is to find out the area of this green shape. From the drawing it is very clear that the area of this green shape equals to the area of the circle minus the area of triangle ABC. So we start with the first method. In the first method I will present to you a new rule and we will implement the new rule in our drawing. This is actually rule number 4. In the drawing of rule number 4 we have triangle ABC. We know that side AB of this triangle equals to A units in its length, side BC equals to B units in its length, and side DC equals to C units in its length. And the semi-perimeter of this triangle, triangle ABC, equals to the perimeter over 2. That is to say it is equals to A plus B plus C, that is the sum of its sides lengths, over 2. So S equals to, the semi-perimeter S equals to A plus B plus C over 2. And the area of this triangle, triangle ABC, according to rule number 4, the area of triangle ABC is equals to, here the squared bracket is a sign for the area, it means the area of triangle ABC equals to the square root of S. S is the semi-perimeter, that equals to A plus B plus C over 2, times S minus A, times S minus B, times S minus C. A, B, and C are the side lengths of this triangle, triangle ABC. So we can actually implement rule number 4 in our drawing. First of all, we define the length of side AB as A. We know that the length of side AB is 13, therefore A equals to 13. We define the length of this side BC as B, and we know that B equals to 14 units in its length. Or side BC equals to 14 units in its length, so B equals to 14. And finally, we define the length of side AC on this triangle, triangle ABC is C. We know that C equals to 15 units, that is to say the length of side AC is 15 units. So I write it down here. A equals to 13, B equals to 14, and C equals to 15. In the next step we will find out the semi-perimeter of this triangle, triangle ABC. According to rule number 4, the semi-perimeter of this triangle, triangle ABC, S, equals to A plus B plus C over 2. That is the perimeter over 2. So S equals to A, that is 13, plus B, that is 14, plus C, that is 15, over 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally, we can find out that S equals to, S, the semi-perimeter of our triangle, triangle ABC, is equals to 21 units. S equals to 21, A equals to 13, B equals to 14, and C equals to 15. And according to rule number 4, the area of our triangle, triangle ABC, it is equals to the square root of S times S minus A times S minus B times S minus C. Okay, so the area of our triangle, this triangle, triangle ABC, according to rule number 4, will be equal to the square root of S. S is 21 times S minus A. S minus A is 21 minus 13 times S minus B times S minus C. times S minus B. S minus B is 21 minus 14 times S minus C. S minus C is 21 minus 15. So the area of our triangle ABC equals to the square root of 21 times 21 minus 14 is 8 times 21 minus 14 is 7 times 21 minus 15 is 6. Here we'll substitute 21 by 3 times 7. We'll substitute 8 by 2 times 2 times 2 times 7, and we'll substitute 6 by 3 times 2. Here we will change the order of the numbers inside the root, and we'll get finally that the area of our triangle ABC according to rule number 4. Here, write down that this is actually the implementation of rule number 4 in our drawing. So according to rule number 4, the area of our triangle ABC is equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2 again. Repeat again. We change the order of the numbers here, and we found out finally that the area of triangle ABC equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. The square root of 3 times 3 is 3, the square root of 7 times 7 is 7, the square root of 2 times 2 is 2, and we have again the square root of 2 times 2, that is 2. 3 times 7 is 21, 21 times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. In conclusion, found out that the area of our triangle ABC is equal to 84 square units. Okay, repeat again. The area of this triangle ABC equals to 84 square units. In the next step, we find out the area of the circle. In order to find out the area of the circle, I will present to you a new rule, and we will implement the new rule in our drawing. In our drawing, we have a circle that blocks triangle ABC. Rule number 6 also relates to the radius of a circle that blocks a triangle. So here, according to rule number 6, the radius of a circle that blocks triangle ABC is equals to R equals to A times B times C over 4 times the area of triangle ABC. In the drawing, we have a circle. Inside this circle, we have triangle ABC. Actually, triangle ABC is blocked by this circle. The radius of this circle is R. So the radius R of this circle, but before that, we know that side AB of triangle ABC equals to units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. So the radius R of this circle that blocks triangle ABC, according to rule number 6, it is equals to A times B times C. That is the multiplication. That is the multiplication of the side lengths of the triangle by each other over 4 times the area of this triangle ABC. So we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have also a circle that blocks triangle ABC. So first of all, we will define the radius of this circle is R. this is the center of the circle. Point O is the center of the circle. We join points O and B together by a straight line. Point O is the center of the circle, point B is the point on the circle itself. So for OB is the radius of this circle. We define the radius of this circle as R. So OB equals to R. So according to rule number 6, because of the fact that in the drawing we have a circle that blocks triangle ABC, then the radius of this circle, according to rule number 6, the radius R of this circle must be equal to A times B times C. Over 4 times the area of this triangle, triangle ABC. This equation is the implementation of rule number 6 in our drawing. A is 13, B is 14, C is 15, over 4 times the area of triangle ABC. We already found out that the area of triangle ABC equals to 84 square units. So it is 4 times 84. Okay. In the next step, we will divide both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1, so we left only with 13 times 15 over, in the denominator we have 4 times 84. So it is 4 times 84 over 14 is 6. So in total, in the denominator we left only with 4 times 6. Here we divide both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in the numerator we left only with 13 times 5. In the denominator we have 4 times 6. So it will be 4 times 6 over 3 is 2. So in total, in the denominator we left only with 4 times 2, that is 8. And 13 times 5 is 65. So in conclusion, we found out that the radius R of this circle that blocks triangle ABC equals to 65 over 8 units. So I write it down. The radius R of this circle is equals to 65 over 8 units. I'll repeat again, that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So I write it down, the area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. Okay. The area of the circle equals to pi r squared. We already found out that the area of our triangle ABC it is equals to 84 square units. So it is minus 84. The area of the circle is pi r squared, but r is 65 over 8, therefore r squared is 65 over 8 squared. So in total this expression equals to pi times 65 over 8 squared minus 84, that is the area of triangle ABC. So actually this expression in total, it is equals to 207.394 square units minus 84. So in conclusion, found out that the area of the green shape in total, it is equals to 123.394 square units. And that is the answer to the question. I repeat again. According to the first method, the area of this green shape equals to 123.394 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will do a construction, that is to say from point A, we will draw a perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and BC as M. We will define the length of side AM as H. And we will define the length of side BM as X. What is the length of side CM? From the drawing it is very easy to see that CM equals to CB minus MB. CB is 14 and MB is X, therefore in total CM equals to 14 minus X. CM equals to 14 minus X units in its length. In the next step, I will copy the right triangle ABM in a new page and we will implement the Pythagoras theorem in this right triangle ABM, or AMB. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle AMB that I copied from the original drawing. AM equals to H and BM equals to X according to our definition. Side AB equals to 13 units according to what is given us the question. By PT is the abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle AMB, AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, it is 169. And it is equals to AM squared. AM is 8, therefore AM squared is 8 squared. Plus BM squared. BM is X, therefore BM squared is X squared. So in total we found out that according to equation number 1, 169 equals to 8 squared plus X squared. Here we subtract X squared from this equation number 1, and we get that according to equation number 1, H squared equals to 169 minus X squared. Okay. In the next step, I'll copy the right triangle AMC in the new page and we will implement the Pythagoras theorem on this right triangle AMC. So actually, this is the right triangle AMC that they go from the original drawing. Side MC equals to 14 or 6 units according to what we already found out. AM equals to H according to our definition. And the opposite AC equals to 15 units according to what is given as the question. Here by PT is evaluation from Pythagoras theorem. So according to the Pythagoras theorem, in the right triangle AMC, AC square equals to AM square plus MC square. AC is 15, therefore AC square is 15 squared, that is 225, and it is equals to AM square. AM is Z, therefore AM square is Z square, plus MC square. MC is 14 minus X, therefore MC square is 14 minus X square. So here we subtract 14 minus X square from this equation number 2, and we get that according to equation number 2, H square equals to 225 minus 14 minus X square. This is according to equation number 2. While according to equation number 1, we have already found out that H square equals to 169 minus X square. So we have two different equations for H square. In the next step, we will create equation number 3 that states that H square according to equation number 1 must be equal to H square according to equation number 2. H square according to equation number 1 equals to 169 minus X square, and it must be equal to H square according to equation number 2. This is actually 225 minus 14 minus X square. So according to equation number 3, we actually found out that 169 minus X square equals to 225 minus 14 minus X square equals to 14 squared, that is 196, plus X square minus 2 times 14x, minus 2 times 14x, that is actually minus 28x. Okay, so actually found out that according to equation number 3, 169 minus X square equals to 225. Here we'll open the brackets. We have minus before the brackets, so it will be minus 196 minus X square. Here minus times minus is plus, so it will be plus 28x. So this is the expression that we got after we opened the brackets. So here we have minus X square on both sides of the equation, so minus X square will get cancelled. In this side of equation number 3, we left only with 169, that is equals to 225 minus 196, it is 29, plus 28x. Here we subtract 29 from this equation, equation number 3, and we get that according to equation number 3, 169 minus 25 is equals to 140, that is equals to 28x. Here we divide this equation number 3 by 28, and finally we get that x equals to 140 over 28 is 5, so x equals to 5. And according to equation number 1, we have already found out that h squared equals to 169 minus x squared. That is to say, h squared equals to 169 minus x squared. X is 5, therefore x squared is 25. So minus x squared is minus 25. 169 minus 25 is 144. So in total, we found out that according to equation number 1, h squared equals to 144. Here we take a root out of this equation and finally we get that h equals to the square root of 144, that is 12. So h equals to 12 units. So we can write here that h equals to 12 units. AM that is equal to h is equal to 12 units. X equals to 5. In the next step, we define the center of this circle as O, and we join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle. We define the radius of this circle as R, so OA equals to R. We will extend the radius OA or AO until it touches the circle. We extend the radius AO by a straight line until it touches the circle. And we will define the touching point of the extended radius AO and the circle as point P. The radius of this circle AO, it is absolutely a straight line. And when we extend a straight line by straight line, the result is a straight line. So the result AP is a straight line. AP is one straight line. But AP is a straight line that touches the circle at points A and P. Therefore, AP is a chord that passes from point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. So I write it down here. AP is the diameter of the circle. And we also know that the diameter of any circle is twice as long as the radius. The radius of this circle is R, therefore the diameter AP must be equal to 2R. AP equals to 2R. Here point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of this circle, that equals to R. From the domain itself, it is very easy to see that the length of AP is R plus R, that is 2R, and indeed AP is the diameter of this circle, that equals to 2R. In the next step, we will join points P and C together by a straight line. By joining points P and C, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is on chord AP, that is the diameter of the circle. And we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I'll repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing we have peripheral angle ACB. This peripheral angle ACB rests on AB, and AB is the diameter of this circle. Therefore, peripheral angle ACB, according to this rule number 7, equals to 90 degrees. We can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP. This peripheral angle ACP rests on chord AP, that is the diameter of the circle. Therefore, according to rule number 7, peripheral angle ACP must be equal to 90 degrees. So I write it down here. This peripheral angle ACP equals to 90 degrees in its size. In the next step, I present to you a new rule, and we'll implement the new rule in our drawing. This is actually rule number 8. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing, we have two peripheral angles. Peripheral angle ADB, this peripheral angle rests on chord AB, and we have another peripheral angle ACB that rests on the same chord AB. So those two peripheral angles, they both rest on the same chord AB. Therefore, according to this rule number 8, they must be equal to each other. That is to say, if the size of this peripheral angle ADB is equal to theta, then the size of this peripheral angle ACB must be also equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle ABC. This peripheral angle ABC, this is peripheral angle ABC that rests on chord AC. And we have another peripheral angle APC, rests on the same chord AC. Again, this peripheral angle APC rests on the same chord AC. So those two peripheral angles, they both rest on the same chord AC, therefore they must be equal to each other according to rule number 8. So if we define the size of this peripheral angle ABC as theta, then the size of the other peripheral angle APC, that also rests on chord AC, must be also equal to theta. In the next step, we will focus on the right triangle APC. On the right triangle APC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, we will focus on the right triangle ABM. In this right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle APC is similar to the right triangle AEMB. So why those two right triangles are similar to each other? So I write it down. First of all, we'll prove that the right triangle AEMB is similar to the right triangle APC. Why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So this is angle ABM in triangle AMB, and it is equal to this angle APC in triangle ACP. Repeat again. Angle ABM in triangle AMB equals to angle APC in triangle ACP. They are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle AMB in triangle ABM, and it is equals to this angle. This is actually angle ACP in triangle APC. Repeat again. Angle AMB in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is actually angle BAM. And it is equals to this angle that is actually angle PAC. Now repeat again. Angle BAM in triangle AMB equals to angle PAC in triangle PCA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles in triangle AMB are correspondingly equal to all the three angles in this triangle, triangle APC. Therefore, we proved that those two right triangles are similar to each other according to angle similarity rule. So I write it down. We actually proved that the right triangle, triangle AMB is similar. This is the sign of similar to the right triangle, triangle APC. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AB in triangle AMB over AP in triangle ACP is equals to AM in triangle ABM over AC in triangle ACP. Repeat again. We derive that AB over AP equals to AM over AC. Okay. AB is 13 over AP. AP is the diameter of the circle that is equals to 2R. And it is equals to AM. AM is 12 over AC. AC is 15. In conclusion, found out that 13 over 2R equals to 12 over 15. Here we'll cross multiply this equation, and we get that according to this equation, 13 times 15 equals to 12 times 2R. Here we'll divide this equation by 12, and finally we get that 2R equals to 13 times 15 over 12. So here we divide this equation by 2, and finally we get that R, the radius of this circle R, it is equals to 13 times 15 over 12 times 2. Here we'll divide both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So it will be 13 times 15 over 3 is 5. So in the numerator we left only with 13 times 5. In the denominator we have 12 times 2. After we divide it by 3 we get that it will be 2 times 12 over 3 is 4. So in total in the denominator we left only with 2 times 4, that is 8. And here in the numerator we have 13 times 5, that is 65. So actually found out that the radius of the circle R equals to 65 over 8 units. And what is the area of this circle and what is the area of the green shape? From the drawings it's very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So I write it down. The area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. The area of the circle is equals to pi r squared minus the area of triangle ABC. What is the area of triangle ABC? From the drawings it's very easy to see that the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h, over 2. Repeat again, the area of triangle ABC equals to the base BC times the height to the base, that is h, over 2. So the area of the green shape equals to pi r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. So in total this expression equals to pi times 65 over 8 squared, that is the area of the circle, minus the area of triangle ABC, that is BC is 14, times h, that is 12, over 2. So this expression, pi times 65 over 8 squared, in total it is equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to this expression, that is, to say it is 14 over 2 is 7, and 7 times 12 is 84. So in total the area of triangle ABC equals to 84 square units. And the area of the green shape equals to 207.394 minus 84, that is actually equals to 123.394 square units. I'll put again. The area of this green shape, in both methods we found out that the area of this green shape in total it is equals to 123.394 square units. We finished with the second method. In the next step I will summarize the lecture. We'll start with the first method, of course. In this lecture, we found out the area of this green shape. In the domain, we have a circle. Inside this circle, we have triangle ABC. We know that side AB of this triangle ABC equals to 13 units in its length, side BC equals to 14 units in its length, and side AC equals to 15 units in its length. Again, our mission is to find out the area of this green shape. From the drawing, it is very clear that the area of the green shape must be equal to the area of the circle minus the area of triangle ABC. Okay, so we start with the first method. In the first method, I presented to you a new rule and we implemented the new rule in our drawing. The new rule is rule number 4. In the drawing of rule number 4, we have triangle ABC. The length from side AB is A units, side BC equals to B units in its length, and side DC equals to C units in its length. The semi-perimeter S of this triangle ABC equals to A times B times C, that is the sum of its side lengths of this triangle ABC over 2. Okay, so the semi-perimeter S equals to A plus B plus C over 2. So according to this rule number 4, the area of triangle ABC, here the square brackets is the sign for the area of triangle ABC equals to the square root of S. S is A plus B plus C over 2, that is the semi-perimeter of this triangle ABC, times S minus A times S minus B times S minus C. A, B, and C are the side lengths of this triangle ABC. So we can actually implement rule number 4 in our drawing. Why? Because in our drawing, actually, this triangle ABC could be any triangle. Therefore, that is the reason that we can implement the new rule in our triangle ABC. So first of all, we define the length of side AB is A, and we know that A equals to 14 units in itself. We define the length of side BC of this triangle ABC as B, and we know that B equals to 14 units in itself. And we define the length of side AC of this triangle ABC as C, and we know that C equals to 15 units, and side AC equals to 15 units in its length. Okay, then so I repeat again. According to our definition, A equals to 14, B equals to 14, and C equals to 15. Then we found out the semi-perimeter of our triangle ABC. According to rule number 4, the semi-perimeter of our triangle ABC equals to the sum of its side lengths, that is A plus B plus C over 2. A is 13, B is 14, and C is 15 over 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 2. So finally we found out that the semi-perimeter of this triangle ABC equals to 21 units. S equals to 21. And we know that A equals to 13, B equals to 14, and C equals to 15. So the only thing that is left to do is to put the data inside the formula in order to find out the area of our triangle ABC. According to rule number 4, the area of our triangle ABC is equals to the square root of S. S is the semi-perimeter. This is A plus B plus C over 2 times S minus A times S minus B times S minus C. Again, S is 21. S minus A is 21 minus 13. S minus B is 21 minus 14. And S minus C is 21 minus 15. So the area of our triangle ABC equals to the square root of 21 times 21 minus 13 is 8 times 21 minus 14 is 7 times 21 minus 15 is 6. So in total the area of our triangle ABC equals to the square root of 21 times 8 times 7 times 6. Then we substitute 21 by 3 times 7, and we substitute 8 by 2 times 2 times 2. Here we left 7 as it is, and we substitute 6 by 3 times 2. So we got this expression. Then we change the order of the numbers inside this root, and finally we found out that the area of our triangle ABC according to the new rule number 4, it is equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. The square root of 3 times 3 is 3. The square root of 7 times 7 is 7. The square root of 2 times 2 is 2. Again, we have 2 times 2 again. The square root of 2 times 2 again is 2. So the area of triangle ABC in total equals to 3 times 7, that is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in conclusion, found out that the area of our triangle ABC, it is equals to 84 square units. So we found out the area of the triangle. In the next step, we have to find out the area of the circle. And the area of the circle minus the area of triangle ABC, that is 84 square units, must be equal to the area of the green shape. In order to find out the area of the circle, I presented to you rule number 6, and we implemented rule number 6 in our drawing. Rule number 6 talks about the radius of a circle that blocks triangle ABC. Here we have a circle. Inside this circle we have triangle ABC that could be any triangle. We know that the length of side AB is equals to of triangle ABC equals to 1 unit in itself. Side BC equals to 1 unit in itself, and side AC equals to 3 units in its length. And according to our definition, the radius of this circle is R. So the radius R of this circle that blocks triangle ABC, according to this new rule number 6, it is equal to A times B times C. That is the multiplication of the side lengths of the triangle by each other over 4 times the area of this triangle ABC that is blocked by the circle. Again, the radius of this circle R equals to A times B times C over 4 times the area of this triangle ABC. You can actually implement rule number 6 in our drawing. Why? Because in our drawing, we have a circle and the triangle ABC is blocked by this circle. We define the radius of this circle as R. So the radius R, according to the new rule number 6, the radius R must be equal to A times B times C, that is the multiplication of the side lengths of the triangle by each other over 4 times the area of this triangle ABC. And we have already found out that the area of this triangle ABC equals to 84 square units. So the radius R equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC, that is 84 square units. Here we divided both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1, so we left only with 13 times 15. In the denominator we have 14 times 84. So it will be 14 times 84 over 14 is 6. So in total, in the denominator we left only with 4 times 6. In the next step we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So it is 13 times 15 over 3 is 5. So in total, in the numerator we left only with 13 times 5. In the denominator we have 4 times 6. So after we divide it by 3, we get 4 times 6 over 2. We have 4 times 6 in the denominator. After we divide the denominator by 3, we get 4 times 6 over 3 is 2. So in total, in the denominator we left only with 4 times 2, that is 8. In the numerator we have 13 times 5, that is 65. So in total, the radius of this circle equals to 65 over 8 units. I repeat again, the radius R of this circle equals to 65 over 8 units, and the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square minus the area of triangle ABC. What is the area of triangle ABC? We have already found out that the area of triangle ABC, it is equals to 84 square units. Okay, so the area of the circle is pi r squared, but r is 65 over 8, therefore r squared is 65 over 8 squared, so in total pi r squared is pi times 65 over 8 squared minus the area of triangle ABC, that is 84 square units. This expression in total, it is equals to 207.394 square units minus the area of triangle ABC, that is 84 square units. 207.394 minus 84 equals to, in total, 223.394 square units. So actually we found out that, in conclusion, that the area of this green shape, according to the first method, is equals to 123.394 square units. Okay, so we finished with the first method. In the next step, I actually presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say from point A, we drew perpendicular on side BC of the triangle. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in BC as M. We define the length of side AM as H, and we define the length of side BM as X. What is the length of side CM? From the drawing it is very easy to see that CM equals to CB minus MB. That is to say, CM equals to CB, that is 14, minus MB, that is X, so in total CM equals to 14 minus X. Then I copied the right triangle, triangle A and B in a new page, and we implemented the Pythagoras theorem in this right triangle, triangle A and B. This is the right triangle, triangle A and B that I copied from the original drawing. AB equals to 13 units according to what is given as the question. AM equals to H and BM equals to X according to our definition. So in this right triangle, triangle A and B, according to the Pythagoras theorem, AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169, and it is equal to AM squared. AM is 8, therefore AM squared is 8 squared plus BM squared. BM is X, therefore BM squared is X squared. So in total, we found out that according to equation number 1, 169 equals to H squared plus X squared. Here we subtracted H squared from this equation number 1, and finally found out that H squared equals to 169 minus X squared. Okay, according to equation number 1, H squared equals to 169 minus X squared. Then I copied the right triangle, triangle AMC in a new page, and we implemented the Pythagoras theorem in this right triangle, triangle AMC. This is the right triangle, triangle AMC that I copied from the original drawing. AC equals to 15 units according to what is given as the question. MC equals to 14 minus X according to what we have already found out, and AM equals to H according to our definition. In the right triangle, triangle AMC, according to the Pythagoras theorem, AC squared equals to AM squared plus MC squared. So AC is 15, therefore AC squared is 15 squared, that is 225, and it is equal to AM squared. AM is 8, therefore AM squared is 8 squared, plus MC squared. MC is 14 minus X, therefore MC squared is 14 minus X squared. So in conclusion, found out that according to equation number 2, 225 equals to H squared plus 14 minus X squared. We subtracted 14 minus X squared from this equation number 2, and found out that according to equation number 2, H squared equals to 225 minus 14 minus X squared. This is according to equation number 2, but according to equation number 1, we have already found out that H squared equals to 169 minus X squared. So we have two different equations for H squared. Therefore, we get that equation number 3 that states that H squared according to equation number 1 must be equal to H squared according to equation number 2. H squared according to equation number 1 equals to 169 minus X squared, and it must be equal to H squared according to equation number 2, that is actually 225 minus 14 minus X squared. So according to equation number 3, 169 minus X squared equals to 225 minus 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. So actually found out that we open the brackets here. After we open the brackets, we get here, it will be equal to minus 196 minus x squared, minus and minus is plus, so it will be plus 28x. So repeat again, after we open the brackets, we get 169 minus x squared equals to 225 minus 196 minus x squared plus 28x. Here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. After we cancel minus x squared, in this side of the equation we have only 169. On the other side of the equation we have 225 minus 196 is 29 plus 28x. So according to equation number 3, we found out that 169 equals to 29 plus 28x. If subtracted 29 from this equation, equation number 3, and found out finally that 169 minus 29 is 140, that is equals to 28x. Here we divided this equation by 28 and finally found out that x equals to 140 over 28 is 5. So x equals to 5. And we have already found out that according to equation number 1, h squared equals to 169 minus x squared. So according to equation number 1, h squared equals to 169 minus x squared. But x is 5, therefore x squared is 25. So x squared equals to 169 minus x squared, that is 25. So h squared equals to 169 minus 25, that is 144. So in conclusion, we found out that h squared equals to 144. We took out of this equation and finally found out that h equals to the square root of 144, that is 12. Here h equals to 12 units. In the next step, we define the center of this circle as O. We join points A and O together by a set line. Point O is the center of the circle, point A is the point of the circle itself. Therefore, AO is the radius of this circle. We define the radius of this circle as R. Then we extended the radius AO. Therefore, AO, it is actually the radius of the circle, that is R. Then we extended the radius AO by a set line until it touches the circle. And we define the touching point of the extended radius AO, and the circle is P. When you extend a straight line by a straight line, the result is a straight line, therefore AP is a straight line that touches the circle at points A and P. Therefore AP is a chord that passes from point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore AP is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius. The radius is R, therefore the diameter AP must be equal to 2R. Then we join points P and C together by a straight line. By joining points P and C, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have rule number 7 that says that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I repeat again, rule number 7. Rule number 7 is if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the domain we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore this peripheral angle ACB equals to 90 degrees. We can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. Therefore this peripheral angle must be equal to 90 degrees according to rule number 7. Then I presented to you rule number 8 and we implemented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing we have those two peripheral angles. This peripheral angle ADB rests on chord AB. The other peripheral angle ACB also rests on the same chord called AB. So those two peripheral angles, they both rest on the same chord called AB, therefore they must be equal to each other. That is to say, if this peripheral angle ADB is equal to theta, then the other peripheral angle ACB that rests on the same chord called AB must be also equal to theta. we can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC. Again, peripheral angle APC, this peripheral angle APC rests on chord AC. But we have another peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles, they both rest on the same chord called AC, therefore according to rule number 8, they must be equal to each other. This is to say, if we define the size of this peripheral angle ABM as theta, then the other peripheral angle APC must be also equal to theta. Then we focus on the right triangle, triangle APC. The right triangle, triangle APC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. 1 equals 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the right triangle, triangle ABM. On the right triangle, triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we actually proved that the right triangle, triangle ABM, this right triangle, triangle ABM is similar to this right triangle, triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in triangle ABM are correspondingly equal to all the three angles in the right triangle, triangle APC. Therefore, we proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AB in the right triangle AMB over AP in the right triangle APC is equals to AM in triangle ABM over AC in triangle APC. I repeat again, we will derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle that is 2R, AM is 12, and AC is 15. Here we cross multiply this equation and found out that 13 times 15 equals to 12 times 2R. Here we divided this equation by 12. And finally we found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2. And finally we found out that R equals to 13 times 15 over 12 times 2. So the radius of this circle R is equals to 13 times 15 over 12 times 2. Here we divided both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it will be 13 times 15 over 3 is 5. So in total, in the numerator we left only with 13 times 5. We also divided the denominator by 3. In the denominator we have 2 times 12. So it will be 2 times 12 over 3 is 4. So in total, the denominator we left only with 2 times 4. 2 times 4 is 8, and 13 times 5 is 65. So in conclusion, we found out that the radius of this circle R equals to 65 over 8 units. And what is the area of the green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square, is equals to pi r square, and the area of triangle ABC, from the drawing it is very easy to see that the area of this triangle, triangle ABC, equals to the base of the triangle that is BC times the height to the base that is H over 2. Repeat again, the area of triangle ABC equals to the base that is BC times the height to the base that is H over 2. So the area of the green shape equals to pi r square, that is the area of the circle. R is 65 over 8, therefore r square is 65 over 8 square. So in total this expression equals to pi times 65 over 8 square minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times H, that is 12 over 2. So this expression in total, it is equals to 207.394 square units. That is to say, the area of the circle equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to this expression, that is to say, it is 14 over 2, that is 7, and 7 times 12 is 84. So in total, the area of triangle ABC equals to 84 square units. And the area of the green shape equals to 207.394 minus 84. That is actually equals to 123.394 square units. In conclusion, we found out that in both methods, the area of this green shape, it is equals to 123.394 square units. Okay, thank you very much.